Good morning. This is your stats sensei, Mr. Spensei, and we're working with two sample proportions, and this is our warm up. So, shift happens. A large company has two shifts, a day shift and a night shift, and each shift has more than 2,200 workers. That sounds like the population. Parts produced by the two shifts must meet the same specification. The manager of the company believes that there's a difference in the proportion of parts. By the way, that might be a key word. Proportion of parts produced within specification by the two shifts. To investigate this belief, random samples of parts that were produced on each of these shifts were selected. Okay, random samples, so more than one. For the day shift, 188 of its 200 parts that were produced on each of the shifts were selected. So 188 out of 200, and this is going to be the day, and this is going to be the night. And so we can calculate our p hat real quickly, which is 188 divided by 200 is 0.94. So this is 188 over 200, and that gives us 0.94. For the night shift, 180 of its 200 selected parts met specifications. All right. So our p hat 2 is going to be 180 over 200, and that's going to be 90%. 180 divided by 200 is 0.90. All right. So we have p hat 1 and p hat 2. Then it says test at an alpha level of 0.01, 0.10. So I'm going to go ahead and record that down here. And you know what? I should have left that up there. But there's our day shift. 188 out of 200 is 0.94. 180 over 200 is 0.90. And it talks about our alpha. So I'm going to go ahead and address that. Our alpha level is 0.10. So that's what they want us to test at. If they're telling us to test, it's a hypothesis test. So HO, P1 equals P2. Our alternative, we know it's P1 and P2. And it says the proportion of parts produced by the night shift less than the day shift. All right. It should say proportion of parts that meet specification is less than the day shift. So P1 has more than the night shift. Because P2 is going to be the night shift because day one, this is P1 and this is P2. All right, the next thing is P hat C. Be careful. So P hat C is not our z-score. P hat C is x1 plus x2 over n1 plus n2. So that's P hat combined. When I plug in, that's going to be P hat C equals 188 plus the 180. And this is going to be 200. And we both have the same sample size. So let's add those up. So 188 plus 180 is 368. So 368, the 200 plus 200 is 400. So 368 divided by 400 is 0.92. So this is our p hat combined. And we're going to need that because it ties into our main formula and it also ties in to our condition. So the first one of our conditions is the random sample condition. And they told us, and so this is going to be the day shift. And this one over here will be the night. And the day has a random sample of 200, and that was given. Turns out the night shift is a random sample of 200, and that is also given. The next thing, we have two independent random samples. Two independent samples. I'm going to go ahead and write it twice since I have the bar there. 2 independent samples. Because this is a simple random sample, we have to do the n is less than 10%. So it's not an option. If it's random assignment, we don't have to do it. But for random samples, we do. So we have to check the sampling without replacement. So n equals 200, 200 times 10 equals 2,000. All right. And by the way, it says 2,200 workers. This should have been 2,200 parts. That's a typo. I'll get that fixed, but 2,200 parts is less than 2,200. Not a whole lot less, but it's still less. Over here, we have the same size sample, so 200 and 200 times 10 equals 2,000. That's less than the 2,200 parts. Once again, that says workers, and I need to change that to parts. That's incorrect. Number 4, we need to do the NP, but because this is a hypothesis test, it's N1 P hat C, and then N1 times 1 minus P hat C. So N1 was 200. So 200 times the 0.92. 200 times 0.92 is 184. And that 184 is greater than 10. Here it's going to be 200 times 1 minus 0.92. And that's going to, when I multiply that out, it equals 16. And that's greater than 10 as well. I have to do the same thing over here. Again, these are my normality condition. Is the sample large enough to use the normal approximation? So this is 200 times 0.92, and that equals 184, and that's greater than 10. And this is N1 times 1 minus P hat C. And once again, it's 200 times 1 minus 0.92, and that equals 16, which is also greater than 10. So basically, all four of these have to meet, and they do, so we're good to go. Now it asks me for the actual formula. An actual formula to run the test is Z equals P hat 1 minus P hat 2 over P hat C times 1 minus P hat C in 1 plus P hat C times 1 minus P hat C. If you'll notice, these are exactly the same, except for the denominators. This is sample size 1, this is sample size 2. And we need to start plugging in. Well, we can see P hat 1 and P hat 2. And I also want to note my alternative was greater than. So we are interested in the probability that Z is greater than. Probability that Z is greater than 0.94 minus 0.90. And P hat C is 0.92. 1 minus that is 0.08, because all I did was go 1 minus the 0.92, 1 minus 0.92, and I get 0.08, so that's where that came from, over 200 plus 0.92 times 0.08 over 200. And the sample sizes don't have to be the same, they just happen to be this time. So we want the probability that Z is greater than, and let's find out. Let's go run this test. So stat test two proportion z-test, which is number 6. We had 188 out of 200. Then we had 180, 200, 180 out of 200. Our alternative was a greater than, so we need greater than. When we calculate that, and we get the probability that z is greater than 1.4744. Equals a p-value of 0.0701. So this is less than, 701 is less than 1,000. So our decision is to reject the null. So in this case, we believe the proportion of parts that meet specification for the day shift is greater than the night shift. All right, we don't believe that they're equal. We believe that the day shift creates more parts that meet specification. All right, appreciate you watching, and I hope to see you on the next one. Thank you.